Lesson 28, section 9.10. This is the last section of sequences and series, specifically the concept of power series, Taylor series, Maclaurin series. Now, we already have this information. I'm not going to go through it again. Example number 2. Now I'm going to do this right on this this note page. It says find the Maclaurin series for f of x, and then it asks us to determine the interval of convergence. So let's start with the finding the Maclaurin series. Okay, how is it that we did that again? Well, we used this formula right here. Okay, this whole thing, such that we're centered at the value of 0. So, as I go through this, the first thing I'm going to want is to be able to find all of the derivatives at the point 0. So, I'm going to go ahead and start out with f of 0. F of 0 in terms of sine of x, sine of 0 is actually going to be 0. That's very important for us. We'll have to keep that in mind. F prime of 0, well, the derivative of sine is cosine. So, that means when I plug in 0, I get a value of 1. Next, f double prime of 0, well, the derivative of cosine is a negative sine. And plugging in 0, well, the sine of 0 is still 0, so this is still 0. It doesn't matter that it's negative. My third derivative at 0 is going to be a negative cosine this time, and I'm plugging in 0. Now, a negative cosine of 0, well, cosine of 0 is 1, so when it's negative, I get a negative 1. If I continue this pattern, okay, f, and I'm going to put a little 4 here for the fourth derivative of 0. Again, the fourth derivative of 0 is going to be back to sine of 0, which is 0. And then the fifth derivative is actually going to be back to 1. And this cycles back around, so it goes 0, 1, 0, negative 1, 0, 1, so on and so forth. So every, well, there's no derivative there, second derivative there, fourth derivative there, the next one would be the sixth derivative, and that would also be 0. So it really looks like every even power of the derivative is going to be non-existent, is going to be unimportant to us, okay? So, when I look at the actual polynomial, p sub n of x is going to be equal to, well, f of 0, which is 0, I'm going to put that in there just so that I have a placeholder, plus the first derivative at 0 times an x, all divided by 1 factorial. So, that's really just going to be 1 times an x, technically divided by 1 factorial. I'll write it in there just so we can see the pattern. The second derivative, well, when I plug in that, I'm going to get 0. Again, if you'll notice over here, the second derivative is 0. So anything in there is going to be 0. I'm going to leave it at 0. I'm not going to put anything else in there. Plus, now my third term, okay, my third term will be a negative 1 for the derivative piece. So it's going to be a negative 1 here, divided by 3 factorial, times x minus the 0 to the power of 3. Plus the fourth term, well, the fourth term becomes 0. Again, every even derivative becomes 0. Then it's plus a positive 1 again over 5 factorial times x to the fifth. Plus a 0 again, plus, and then I'm going to go ahead and repeat the negative 1. Okay, that's going to occur, x to the seventh. So, if you want to see this all written out as one type of polynomial, f of x is supposed to be approximately equal to p sub n of x, which is going to be equal to x minus x to the power of 3 over 3 factorial, plus the fifth term, minus the seventh term, plus, and so on and so forth. Again, this continues on forever until I have, you'll notice the pattern ends up being plus negative 1 x to the n blah 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 over n factorial. Now keep in mind that there's a negative 1 alternating symbol here. Okay, again, every other term that I have is plus minus plus minus plus minus. So this here is the actual series. Now let's actually go ahead and determine it in terms of the series sum notation. N equals 1 to infinity of. Now I need every odd term. First, third, fifth, seventh, so on and so forth. How do I get every odd term? Well, I do x to the power of 2n. Now, is it minus 1 or is it plus 1? Well, if I put a minus 1, I'm going to go ahead and start with that. If I put in a minus 1, I get 2 times 1 is 2, minus 1 is 1, I get power of 1, that would work there. That's actually what I want then, okay? And I'm going to have 2n minus 1 factorial in the denominator. The last piece is the negative. How do I deal with the negative? Well, I want the first term negative or positive and the second term negative. So if I do it n, it's not going to work because if I plug in 1, I'm going to get a negative 1. I don't want my first term to be negative. I want my second term to be negative. So I need n plus 1 or n minus 1. Doesn't really matter as long as this ends up being what it should be. Now, the question is right here for this particular series, okay, what is the interval of convergence? Well, if I'm playing with this series, and I've got factorials, I've got awkward powers, I've got powers for a negative number, chances are I'm going to use ratio test, so I'm going to do that over here, okay? I didn't leave myself too much room, but I'm going to go ahead and write down ratio test. And the ratio test says I'm going to go ahead and take the limit as n goes to infinity of the nth plus 1 term. So I'm going to have a negative 1 to the power of n plus 2. Again, plugging in n plus 1 for n, that gives me n plus 1 plus 1, which is n plus 2. X to the power, and I'm going to write this one out so we don't screw it up, n plus 1 minus 1. This is all divided by 2 times n plus 1 minus 1, that thing, factorial, multiplied by, again, so it's this thing technically divided by this term, okay, but I'm going to flip this term to avoid having to waste my space that I have. Go ahead and draw that line across, okay. So it's this thing times this term flipped, so 2n minus 1 factorial divided by negative 1 to the power of n plus 1 times x to the power of 2n minus 1. Let me simplify this limit as n goes to infinity. If I have negative 1 to the power of n plus 2 here, let me clear that up a little bit if I can. N plus 2 and n plus 1, that means I'm going to have one additional negative 1 up here than I will down here. So I'm going to do absolute value of negative 1 on top. Not that it'll matter inside the absolute value, but just to say that we've done it. Now up here, what is this power for x? Well, that's going to be 2n when I distribute the 2 plus 2 minus 1. So it's really 2n plus 1. But I have 2n minus 1 down here. So how many do I really have? Well, there's 2n here, there's 2n here. There's one extra on top and one less on the bottom. That means I'm actually going to have 2 left over on top. So x to the power of 2 on top. Now let's talk about the factorial. Well, I have 2n minus 1 factorial on top, and down here, this is going to distribute through. I'm going to have 2n plus 1 factorial. Again, I'm going to have 2 more factors down here than I will up here. So what are those factors going to be? Well, one of them is going to be the 2n plus 1. The other one's going to be 2n. Again, because the next term would be 2n minus 1, but the 2n minus 1 factorial cancels out with this 2n minus 1 factorial. So this is what I'm left with. What is the rules for the ratio test again? The ratio test says the limit is convergent, or sorry, the series itself is convergent when this thing is less than 1. Okay? When this thing is less than 1. Now, what I'm going to do is I'm going to go ahead and pull out all the things that don't deal with n. Okay, and I'll go ahead and take the limit of that. So it's going to be absolute value of negative 1. That doesn't matter. I'm going to cross it out. So the absolute value of x squared, not that the absolute value matters because x squared is always going to be positive, of the limit as n goes to infinity of the absolute value of 1 divided by 2n plus 1 and 2n. This thing will always go to 0. But wait a second. If this thing goes to 0, that means that 0 times this is always equal to 0. So it doesn't matter the x values. What does that mean for our radius of, or our interval of convergence, or our radius of convergence? That means my interval is actually equal to negative infinity to infinity. Because I can pick any x value, and no matter what x value I pick, as long as I pick a number, this whole thing is still going to go to 0. And that's still less than 1. Okay, so with that being said, what did I actually do in this entire problem? Okay, let's talk about what I did in this entire problem. I said, let's determine the Maclaurin series for sine of x. So we have f of x is approximately equal to this thing, which is approximately equal to this series right here. I'm going to put this all in a box, okay? This thing right here. And then I said, let's determine the interval of convergence. So I'm saying, where is this series equal to this function? Where does that happen? Everywhere. So as n goes to infinity, this series perfectly represents, again, this series perfectly represents the sine function. Now, I think that's extremely interesting, okay? Think of it this way. We now have a graph that for no matter what x value I want to pick, this is a perfect approximation of the sine function. And it's polynomial, which means that I can do a lot of things to it that don't have to be awkward like it is with the sine and cosine functions, although those are generally really nice functions, okay? Now, I don't have very much time left. In these next next I think 4 parts, it says example 3a, b, c, and D. What I'm going to do in this video is I'm just going to go ahead and write down what those first, third, and so on and so forth polynomial approximations are. Okay, p sub 1 of x is really just equal to the function x. P sub 2, of 3 of x, because 2 won't matter. When I do 2, 0th term, first term, second term. The second term actually goes to 0, so I'm looking at the third term piece. So it's going to be equal to x minus x cubed divided by 3 factorial. I'm going to flip this page over. The fifth term is going to be p sub 5 of x is equal to x minus x to the power of 3 divided by 3 factorial plus x to the power of 5 divided by 5 factorial. And then lastly, this one right here is going to be p sub 7 of x is equal to x minus x cubed divided by 3 factorial plus x to the 5th divided by 5 factorial minus x to the 7th divided by 7 factorial. Again, notice it alternates positive, negative every time. What you're going to do, okay, is you're going to simplify all of these values. Now, this one's fine, okay, we're not going to change this at all. This next one here, I want to write this out as what it is so I can type it into my calculator. This is x minus x to the power of 3 divided by, well, 3 times 2 is 6, times 1 is 6, so it's that function right there, okay. This one right here, I'm going to go ahead and change this. This thing is equal to x minus x to the power of 3 divided by 6 plus x to the 5th divided by, now 5 factorial is going to be 20. Again, 5 times 4 times the 6. So 20 times 6 is going to be 120. And lastly, let's do this last one before my time runs out here. And this is going to be equal to x minus x to the power of 3 divided by 6 plus x to the power of 5 divided by 120 minus x to the power of 7 divided by, now this one I can't do in my head very quickly, so I'm going to go ahead and type in my calculator. In my calculator, I'm going to have 120 times the 7 times the 8, and you're going to get 6720. What you're going to do next, and what I'll do in the next video, is type all of these in. Okay, and I'm actually going to do this very quickly off the grid and show it to you in my calculator what the graphs really do. There's a good visual in your textbook on page 679 to look at to see those graphs.